Welcome back to Bazai. Tudum is Netflix's official home for behind-the-scenes stories and rich, media-heavy pages, serving tens of millions of visitors. The original design used CQRS, a write path for editors in the CMS, and a separate read path for fast page delivery, bridged by Kafka into a read-optimized store. It scaled well, but previews lagged. Editors waited through processing, storage, and cache refresh cycles before seeing changes. Early CQRS design. Editors save content in the CMS. An ingestion service applies templates, validates fields, resolves assets, and emits events to Kafka. A data service consumes events, writes read-optimized records to a Cassandra backstore, and an API serves at page construction and personalization. A near cache in front of the store refresh per key, on a schedule, great for production traffic, but painful for previews. Large pages with many fragments refreshed unevenly, so parts updated while others stayed stale. This eventual consistency change slowed creative workflow and collaboration. The shift raw hollow. Netflix replaced the I/O heavy read path with raw hollow, a compressed, distributed, in-memory object store embedded in each service. Instead of fetch from a key value store via cache, every service instance holds the read-optimized dataset in RAM. Lookups become in-process and O1. Updates propagate to all instances. Compression keeps the footprint tiny. Years of content fit in a few hundred MB, so co-location is practical. Crucially, services can opt in to read-after-write consistency for previews, guaranteeing editors see changes instantly. New architecture. No page data service or near cache in front of Cassandra. No per-request network reads for render. No Kafka dependency on the read path. Raw hollow manages distribution of the in-memory state. Each microservice, page construction, search, personalization, embeds a hollow client and reads locally. Write path still transforms CMS content into a read-optimized format, but once produced, raw hollow updates every consumer's local state. Impact. Latency. Home page construction dropped from roughly 1.4s to about 0.4s in controlled tests once all read path services consumed hollow state. Editorial preview. Near instant with per request strong consistency, removing minutes-long cache waits. Simplicity. Fewer moving parts, no near cache timers, fewer cache invalidation issues, and less network I/O. Memory efficiency. Compressed, co-located data makes full in-memory reads viable without scaling hardware aggressively. Lessons for architects. Keep hot, read-optimized datasets as close to the application as possible. Prefer in-process reads for latency-critical paths. Minimize sequential hops, each network call, and cache policy adds delay and inconsistency windows. Provide selective consistency, eventual by default, strong on preview or critical flows. If this deep dive helped, like and subscribe to Bazai, and drop which red bottleneck is the top pain today: caches, network I/O, or inconsistent previews.